So this is a love story. It's about my lamp. And cue the music. I'm kidding. Okay. So I'm just gonna go off of this because I'm gonna be bouncing back and forth from slides to like actual code and things like that. So this is good enough. So I love my lamp and I'm gonna tell you why. And I really love my lamp. I'm gonna demo out like how this project actually started and where it's at now. Oh, sorry. I'm gonna demo out how this project started and where it's at now. How it evolved over time, its current state. We're going to break apart the components and we're going to go one by one through a few of them. I actually have a couple that are on the Raspberry Pi that I wanted to migrate off, but there were some issues there. So I'll talk about them at a high level. So always start with the why. So why do this project? Why even start with this? So this gives some context into the problem that I'm solving and why I chose these components and where I'm at with things. So here's the problem. My lamp is way back there. And I don't know if you could see that. Actually, let me just do this. And then, can you see me jumping over my couch trying to get to my lamp? Like the switch is back there. And like this is another representation of that. Here's the switch. I have to jump over my couch in order to turn on and off my lamp. And this is how much I love my lamp. Like I created this project to fix that. Also, it's really just cool building stuff. I love Python. I love building things. I'm a software engineer. Been doing it for a few years. So this is a cool project to take on because I don't do a lot of stuff with physical devices with my day job. So this gives me an outlet to do that and build something physical, which I really enjoy. So I'm going to start with a demo. This gives context into how this started. So this is a demo of the working software component of this, and then I'm going to go into a demo of the working hardware component of it. So this started as an American Sign Language learning app. So you can actually just is it right-handed? Do like actual American Sign Language alphabet and then numbers like straight here, and you can learn it and then teach it. What's interesting about this, there's a human computer interaction thing going on. I don't know what you actually call it, but the expectation when you get that feedback of the camera is that there's some lag already there. So you're kind of putting yourself into the world of that entity. But when you're dealing with physical devices, you don't really have that. So when you interact with a physical device, you expect it to immediately turn on or turn off, and there's some issues there. With this, you don't. So it's kind of a seamless interaction, which I found to be interesting. I think that this works better than the actual hardware device, which is true. So this is fun. This is publicly accessible. So go ahead and use it. Teach yourself the American Sign Language learning alphabet. Teach yourself words. Go for it. Go haywire. The code here is also public. It's running on the browser. So it's Python that's available using PyScript. So use it, extend it, tell me about it. I want to know about it. So cool. So yeah, that's how it started. And then if you look over here, I have a lamp. I also love this lamp. I love all lamps. But this one's cool because it's portable. So, and if you gesture to the camera, turns on, turns off. Takes a second. I don't like, but turns on. So that's something. Yeah. So this is all using Python. So we're going to go through the components and break it apart. So the big thing that it's using is MediaPipe to do. It's a pre-trained neural network that you can put to just realize things and to recognize gestures. So I'm going to go through some of the documentation there. It's basically an off-the-shelf solution if you don't want to train your models, which I don't really want to do, but at this point I think it's necessary because what's out there, any competitors to that model don't work well at all. So this is the cutting edge of that. So pre-training your own models with your own like leading indicator factors like is the way to go at this point. And so the next phase of that will be retraining those. I'll go through the gesture recognizer, the base class that we've created. There's a I'm using a GPIO to interact with the actual pins here. So it's a Raspberry Pi with like 24 pins. And then you create a circuit with that, and then you can control the voltage to those. There's also, I created a switch state, and I'm going to go through that a little bit as well. State isn't captured in your Python code, which makes sense. It can be if you store it somewhere, but I'm not storing it anywhere. I'm just running Python code. State is stored in the actual device itself, so there's could be a disconnect. So that was a learning there. And yeah, so just kind of going through it. Here's MediaPipe's like library. They have their own gesture recognition task guide, which I don't think is as reliable as using your own. So if you just do your own error function on your own gestures, it's a lot more performant because you're not going through their library. You're not dependent on this black box entity that you know nothing about. So that's my advice on there. Yeah, not a ton, because it's basically it outputs these 20 points on an XYZ axis, and then you can do your logic on that. And so that was like phase one, and then phase two was creating gestures that are recognized by that, and then we're here where we're integrating that into actual devices. The leading competitor to this is MMPose, and actually, let me go back here, just kind of breaking it apart. I'm going to go through the pros and cons of MediaPipe. MediaPipe is state of the art, but MMPose is I would say the leading competitor to that. And then the pros and cons to using each. So pros, pre-trained, you don't need to do very much. Cons, hard to retrain and extend those models. MMPose, you can extend those models because each of these models over here, if you look here, each point here is its own model. And so if you want to retrain these, you can't do that with MediaPipe. You can with MMPose. So it's a little bit easier to pick up somewhere here than it is somewhere here. Some cons to MMPose, it's very hardware dependent. So all of their models are pre-trained and packaged per CPU, which is kind of a problem. But it's still workable. So pros and cons, I'm kind of going through both. MediaPipe is the easier option, so that's where we're at. We're probably going to start extending MMPose and start experimenting with that, or just creating our models from scratch, which is another option. I think it's probably equally as hard to extend it from MMPose than it is to create models from scratch. So I'm thinking we just create models from scratch. So I'm going to go over the gesture recognizer over here. So this is the actual gesture recognizer. This is where it's put together. It doesn't have the pins part of it, but the pins part of it is maybe like 5 lines of code. Some of you have seen this already. It's just an extension of other projects that I've worked on, so it's pretty much the same. You'll see I set up a class over here. We set up holistic. So this MediaPipe holistic, their holistic model is running pretty much everything all at the same time. And then some variables that you put in, and then gives you a context manager. These are for drawing the landmarks, which you don't do on the Raspberry Pi. There's no use in doing that. But after you get that, you get a NumPy's array, and then you can compare that to your error function, which are your gestures. So where are my gestures? My gestures are going to be inside of gesture.base over here. So I'm going to navigate to that. So transcribe ASL gesture and then gesture base. So this actually does the gesture recognition over here. And you're going to see I initialize it with a bunch of gestures that I want to recognize. And so I'm recognizing all of these that I've named manually. And then there's some movement gestures as well. So those are just series of static gestures that happen one after the other. So that's why you have an array of, a dictionary of arrays, because one has to happen after the other. And then so down here, we have a classification function and predict function. So the predict function down here is where it actually does the comparison. You're going to see some errors. it compares it against all the gestures and then gets the errors against all the gestures and then sorts that and gives you the top 5 of that. It's a little bit non-performant, but it does work. So it does work up to like 20 because you're looking at CPU cycles that just can handle that. And then it's also vectorized, so it scales pretty well. So that's how that's done. And then I just stick GPIO, RP GPIO on top of that. And then just when the script starts, I flash it. I always like throw some voltage at it in case a pin is in a like an off state previously. I want it to make sure that it's on an on state. So I just like throw some voltage. And that's the state thing that I was talking about earlier. And then just when I recognize a static gesture as being a 5, which is doing it now, then it'll switch off on and off. So yeah, that's pretty much it for what we're doing here. Yeah, so some learnings. So gesture recognizer here, some learnings. Different voltages for board versus relays. So each device is going to have their own voltage. And I got into some weird lands of having to do like a voltage changer, and that's not the right way to go. You can actually configure it right in your library to send out a different voltage because you, on a Raspberry Pi, you support a voltage range. And I'm sure Andrew can talk a lot more in depth about that. He's like the go-to person when it comes to robotics, which is definitely in the realm of robotics here. But yeah, so does not store a state. So that's why I had to flash it at first. I had to send a voltage through just to make sure that it was on. And then after that, I flipped it either on or off. There's no feedback, so I can't really tell what the switch state is in when I turn on the script. So unless you know of a good way, I don't, I just can't tell. So I had to assume that it was off and then turn it on, or vice versa. So what does the future look like? What am I going to do with this project? So a few things. Low light conditions don't work too well. It does work okay with infrared, but it's really not that performant. So I want to look into that. And plus infrared cameras, you're dealing with like heat issues. You're dealing with a lot of different stuff. There's also a lag component here. So I want to really perform or have performant models that work even before you make the gesture. So if I'm making the gesture of 5, I want to have that as an input and then actually do the switch instead of waiting for the gesture of 5. I also want to include more models, more logic into that, because like what I noticed during the presentations, even if you wave your hand at it, it's going to turn off and on. You need another like input into it to make sure that you're interacting with it. So maybe some facial recognition where it recognizes a face and then it turns on after you make that gesture. That makes a lot of sense. But I'm open to ideas, so I'd love to discuss it and talk about different solutions for that. So yeah, that's pretty much it. That's where we're at with things. Thank you. Reach out if you want to collaborate.
Questions?
Oh.
The beaver in your slides, or is that a cat?
Yeah, that came with the template, and I thought it was along the lines of just it being silly, and I'm like, I'll leave it in there. So sorry if it's confusing. No beavers were harmed in this process. Oh, is it capybara? Oh, cool. Oh, yeah, that's capybara.
Hey, sorry. I'm curious. I don't know if you've ever heard of something called Home Assistant. It's like it's more for like smart home stuff. So you probably actually wired your lamp, is what I'm guessing. But I know you mentioned you're into like or the physical things right now, so that's cool. But Home Assistant might provide you some of those like state features you're mentioning, because the gesture thing would be super cool. I'm looking at doing Home Assistant for my house right now. It can interface with like smart switches, smart light bulbs, all that sort of stuff. It can even like turn your TV on. So I don't know. I'd be curious to see like if I could have a gesture that could do that stuff, that'd be cool too. Yeah.
Oh, yeah. Hi. Really cool presentation. So thanks for giving it. I guess I know you talked about improving the latency towards the end. I'm just curious, like, is the main bottleneck for that right now, is it waiting for the inference from the model you're using on the hardware?
Yeah. Waiting for inference, and it's a deep learning system, so multiple layers have to be processed. So if there's some way to create a simpler model with one layer, I think that's maybe the way to go, but that'll probably come out in experimentation. I'm open to ideas if you think there's a better, maybe Boolean logic somewhere, like you see some leading indicator factors somewhere. Definitely.
Well, maybe the gestures were different enough. So like as you're coming and you're,
yeah,
and then make a different one to get away.
Sorry, go
I
ahead.
had two questions. One was a hardware one. So you mentioned that you are using a relay in there. So are you wiring into essentially the mains with some kind of switch in there that you're triggering with the voltage from the Raspberry Pi GPIO pin? Or what is stopping the lamp from being on?
Yeah, good question. So it's a kit, which is really nice. So it's this relay kit from somewhere, and it has a bunch of options for like normally on, normally off, always on, and then so it makes it so I don't have to shock myself by like rewiring stuff, because there's a relay, like a $2 kit. This is like $30 or something. So yeah, it made sense to go that route. The pins over here, I could show you those. So gosh, okay. All right, here we go. So what's my understanding with this, and this like pushes the boundaries of what I know about Raspberry Pi and Arduino, is that you have to create a circuit of some sort, and keep me honest here, Andrew. But so you have to connect something to ground, and that's kind of where we're at. So I have two connections, one to GPIO 23, and then another one to ground to create that circuit. And which kind of throws me off, because I always think of ground as like the safety route that you would have to go to like ground it, but I guess it has to create a loop of some sort. But we can discuss that with Andrew afterwards, who probably knows more. And then so a circuit is created there, and that's how you output your voltage and get that feedback. So.
Well, and then the other one was just, is the model running on the Raspberry Pi? And did you run into any issues with like performance of that model? Maybe a bigger Pi would work better. I think it died. So maybe.
No. Yeah. So it does perform pretty well on a Raspberry Pi. I don't think it's completely parallelized. So I think there's some issues there. And it's also not using a graphics card to completely parallelize things. So those are options that I looked into. So the other option would be a Jetson Nano that has like a graphics card built into it. That's kind of like this. I'm not seeing huge performance gains with computers with graphics cards though. So if I run this locally, I'm still seeing that lag. So I'm thinking there's something wrong with the models, but it's kind of speculative at this point. I haven't really benchmarked it. So good feedback. I can explore that. Yeah.
There's other accelerators like Google Colb and I think what you said, Jetson Nano. But there's also I saw in Micro Center they have a AI camera where it does processing in the camera. So look into that.
Yeah, I would love to see it. Yeah.
Two questions. Is there a good reason why it was like images and gestures versus like voice commands? And second, are you limited to like what types of lights you can connect? Like, can you connect hue lights or only specific kind of lights? Yeah.
Yeah, I mean, it's Python code, so I'd imagine you can connect it to hue lights or anything with an API, Home Assistant is definitely like something to explore. I'm excited about. The reason I chose gestures versus the like your voice is because I feel it gives you more fine-tuned control over the world around you. Also, there is a market for people that can't use their voice, especially people with spinal cord injuries. So I have a family member who's like buying like 5 of these, and then literally just buying the hardware, and I'm just like installing it and seeing if it works for them because I want to make their life better. So there's a market out there. That's something outside of voice recognition. So
Thank you.
sure.
So when you make a gesture, how do you program it to actually do, like, does it turn it into like a token that then you conditionalize somehow? Or like when you're trying to say like, hey, turn on the light, you have a gesture and it turns into some sort of like text that you then put into a condition. I guess that's the question.
Yeah, so I can show you that object. It's literally just, we're comparing a bunch of 20-point XYZ coordinates. We're putting the bounding box around those XYZ coordinates so it's not outside of the bounding box, which for good or for worse, like it works for simple gestures, but not big gestures. Like this gesture, it wouldn't work for, but like 5, it would, because you're only looking at your hand. So if the bounding box is around your hand, you're fine. So let me show you the code that actually does that. I misplaced it. Okay, here it is. So the code that does that, so you can see in this out object here, it's an output object. So I'm going to go down to that output object and show you all the fields. I go back and forth on strict typing. Sometimes I love it, sometimes I don't. In this case, I love it because it's self-documenting. So here you are. It's just a list of static gestures. So I iterate through these output objects, and then every single static gesture that equals 5 in the top 1, then I make the assumption that it's closer to this gesture than it is to like this gesture. And then it's good enough. And then I say, okay, great, change the voltage on the pin. So no tokens yet, but I would love to discuss tokens with you. I'm not familiar with that pattern and how it could work. So
which Raspberry Pi are you using and how much memory?
yeah, so I have a 4B, I believe, and I want to say it's 8 gigs of memory. Not positive though. So yeah.
Cool, thank you.
Sure.
To piggyback off that slightly, I saw today a 16 gigabyte Raspberry Pi was released. I don't know if anyone in the room is excited about that. I'm not particularly, and I don't imagine this use case would be served well by it, but it's today, so fun. My question is, in terms of just each of those 20 points being just a trio vector, how does it choose an origin to assign those to? Is it just like the farthest leftist one is automatically the origin, or is it like, can you discuss that?
When you're talking about origin, are you talking
like a vector is a trio of numbers, X, Y, and Z coordinate relative to some 0, right? So like, I have to assume that there's some equivalence between this gesture being here and the same gesture being over here. There's not some like origin that's elsewhere in the room. Or is the origin somewhere contained in the bounding box, or is it the lowest leftist farthest corner in the bounding box? Or
yeah, from what I've seen, it's a little bit janky. Sometimes when you move your hand, it messes with it a little bit, but it's pretty good. And I would say it doesn't default to the bottom or anything like that. It defaults to it. There's a central point right here that it looks for. And if I could show you the documentation on that. So I'm making some assumptions here. This isn't really well documented how their models actually work underneath the hood. It's probably better documented in MMPose than it is here. But if you look, this central point right here is probably where it the origin point that you're talking about.
Okay.
And then everything else just spawns after that, because this probably has a very different model when you're looking for the top of someone's hand than the rest of everything. And then you probably have a small decision tree on that as well. Like if it's over here in space, it's probably not one of those points, but yeah. So
Pretty cool.
Hey, can you hear me? Okay. I was wondering if you had any issue like running like the application or running it on the device like for long periods of time, like days, weeks, or something, like hitting problems on the Raspberry or memory issues with like the application running?
yeah, good question. With infrared cameras, they get very hot, and that's one big learning that I've had. So they weren't great, but it's been running now for like 2-3 hours without issue. I probably want to explore something a little bit more efficient, like packaging it more efficiently than before, like selling it or something of the sort. Because a Raspberry Pi, there's a lot of extra OS like going on, so I'd want to extract that. But yeah, no issues so far. So if you're interested in using this Python script as is, it does work. So
Any more questions? All right, let's hear it for Jimmy.